Okay, then what I am saying is, now the one more part of the polar plot is he is asking the magnitude. Okay, similar to that particular topic, we'll solve one question. Now by considering the transformation, g of s equal to k by 1 plus st1 into 1 plus st2. Now he is asking, determine magnitude of the polar plot, determine magnitude of the polar plot where polar plot crosses negative imaginary axis. This is the question. Determine magnitude of the polar plot where polar plot crosses the negative imaginary axis. Then how it is possible? So if this is possible when the plot is really crossing the negative imaginary axis. So first we want to draw the polar plot, again magnitude, again frequency, again phase, and it will take more time. So now use your shortcut methods. Now use your shortcut method to draw the polar plot directly without doing magnitude and phase angle calculations. Is it right or not? Yes. Can I use the type and order approach? Left hand side, these poles are on the left hand side and therefore denominator. So only type and order approach can I use. What is the type and order approach? See here, type and order approach. Type is 0. What is type 0? This is type 0. And order 2. This is order 1. This is order 2. Therefore, this is the polar plot omega 0, omega infinity. Yes. Now your polar plot is crossing. Now your polar plot is crossing the negative imaginary axis. Now the polar plot is crossing the negative imaginary axis. Now see here, the polar plot is crossing the negative imaginary axis. Now here he is asking to find magnitude. Now where the polar plot is crossing the negative imaginary axis, there he is asking to find the magnitude. Just before this problem I am explaining, alright, one examples how to calculate the magnitude. Now where he is asking to calculate the magnitude. So he is really the plot is crossing the negative imaginary axis or not? Yes, if the plot is crossing the negative imaginary axis, there we can calculate the magnitude. Let us assume this magnitude is A. Now you tell me, at this particular point, magnitude is A, exactly phase angle is what? How much? This is a minus 90 degrees. Therefore, negative imaginary axis, phase angle is minus 90 degrees. Now this is magnitude, phase angle at some particular frequency. I don't know. Let us assume omega x. Okay. So a frequency is omega x. I don't know. Magnitude I don't know. I want to calculate that. But angle exactly I know, which is minus 90 degrees. But what is the actual magnitude of this polar plot? What is the actual magnitude of this polar plot? G of j omega, which is nothing but k divided by 1 plus j omega t1, 1 plus j omega t2. So what is the magnitude? The magnitude of g of j omega. The magnitude of g of j omega, which is equal to k divided by square root of a square plus b square, square root of a square plus b square. Now this is the magnitude of the polar plot where the polar plot crosses the negative imaginary axis. This magnitude is called as A at a frequency of omega x, Now when the plot is crossing the negative imaginary axis, the frequency is omega x, magnitude is A. Now if you have omega x, then you can easily calculate the magnitude. But what is the phase angle? The phase angle is angle of g of j omega. What is the angle of g of j omega? Which is equal to denominator minus tan inverse imaginary part by real part minus tan inverse imaginary part by real part. When this phase angle is exactly equal to minus 90 degrees, then this particular frequency is called as omega x over. So from here you can find omega x, minus minus cancel, tan inverse omega x t1 plus tan inverse omega x t2, which is equal to minus minus cancel, 90 degrees. Tan inverse A plus tan inverse B. Tan inverse of A plus B omega x t1 plus omega x t2 by 1 minus omega x square t1 t2, which is equal to 90 degrees. Tan inverse, if go to that side, tan 90. Tan 90 means infinity. Infinity means 1 by 0. Therefore, which is equal to omega x t1 plus omega x t2 by 1 minus omega x square t1 t2, which is equal to 1 by 0. 1 by 0. Now this is a cross multiplication. Then if you do the cross multiplication, so 1 minus omega x square t1 t2 equal to 0. Therefore, omega x equal to 1 by root t1 t2. Note down. Now see here, this is the frequency 1 by root t1 t2 radians per second. Now this is the frequency. At that particular frequency, then we need to find the magnitude, right? Now what is the magnitude? Now omega x you know, then substitute here. Now which is equal to k divided by square root of 1 plus, what is omega x square? Omega x square is nothing but 1 by t1 t2 into t1 square. Square root of 1 plus, what is omega x square? 1 by t1 t2 into t2 square. Now t1 cancel, t2 cancel, which is equal to k into root t1 t2 by t1 plus t2. This is the magnitude where the polar plot is crossing the negative imaginary axis by considering the transfer function. Okay, if the problem is of same kind, if the similar problem is given, if the problem is of same kind, so for example, if the problem is like this, g of s which is equal to 20 by s plus 1 into s plus 2. Two simple poles. Now the same question is asking, determine the magnitude where the polar plot crosses the negative imaginary axis. Now directly you can substitute here, but don't substitute directly. This is time constant form. This is which form? Pole zero form. So converted into pole zero form to time constant form. G of s which is equal to 20 by 1 into 2, which is nothing but 1 plus st1 into 1 plus st2, which is equal to now k by 1 plus st1 into 1 plus st2. Now substitute here, k equal to 10, t1 equal to 1, t2 equal to 1 by 2. Therefore, which is equal to 10 into root 1 into 1 by 2 by 1 plus 1 by 2. Substitute, you can get the answer. Okay, no doubt. Okay, so before you apply the formula, then you cross check whether your problem will in the same form or a different form, then otherwise you will be converted. Okay, now this is the way how to calculate the magnitude in anywhere on the polar plot. When the polar plot crosses negative relaxes, positive relaxes, therefore you can cross check. Okay, so now the similar kind of one more problem, k by s into 1 plus st1 into s plus t2. Determine the magnitude of the polar plot where the polar plot crosses negative real axis. This is the question he is given. Okay, determine the magnitude of the polar plot where the polar plot crosses negative real axis. So first what I am saying is, now first of all your given polar plot is really crosses that particular axis or not. If your polar plot is not crosses that particular axis, I am unable to calculate the magnitude at that particular point. So this is the polar plot which is given. So can I apply type and order method to get the plot directly? Yes, because all are finite poles and finite zeros. Now what is the type? Type is 1. Where is type 1? This is type 1. What is order? Order is 3. Order 1, order 2, order 3. This is omega infinity. This is omega 0. This is the polar plot. So definitely our polar plot is crossing which axis? Negative real axis. There he is asking to find the magnitude A. Okay, very simple, same procedure without any deviation. This is the magnitude A, but you know this is the magnitude A. Exactly the phase angle is how much? Negative real axis means what is the phase angle? Minus 180 degrees. At minus 180 degrees, you know the frequency. Don't say omega x, omega y, omega z. Because earlier I don't know, therefore I can call it as omega x and omega y. But when phase angle is minus 180 degrees, this particular frequency is called as phase crossover frequency. This particular frequency is called as phase crossover frequency. When phase angle is equal to minus 180 degrees, then this particular frequency is called as phase crossover frequency. What is the phase crossover frequency? The phase crossover frequency is the frequency phase angle equal to minus 180 degrees. But what is the exact magnitude here? So what is actual magnitude? 0 plus j omega. Magnitude is square root of a square plus b square. Now when this magnitude we call it as a, this magnitude we call it as a at a frequency of omega pc, phase crossover frequency. This is phase crossover frequency. This is phase crossover frequency. What is the phase crossover frequency? Phase crossover frequency, the phase angle is minus 180 degrees. So this is nothing but minus 90 degrees, means minus tan inverse imaginary part by real part. Therefore, minus tan inverse. Now this is the phase crossover frequency because this phase angle is exactly equal to minus 180 degrees. Now in minus 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 is cancelled. Therefore 90 degrees plus tan inverse omega pc t1 plus tan inverse omega pc t2, which is equal to 180 degrees. So if this 90 degrees is going to that side, tan inverse omega pc t1 plus tan inverse omega pc t2, which is equal to 90 degrees. So this will be same. Omega pc t1 omega pc t2 is 90 degrees. Tan inverse a plus tan inverse b. Tan inverse a plus tan inverse b by tan inverse a plus tan inverse of a plus b by 1 minus ab, which is equal to 90 degrees. Then this tan inverse is go to that side. Omega pc t1 omega pc t2 by 1 minus omega pc square t1 t2. 1 minus omega pc square t1 t2 equals 0. Omega pc, which is equal to 1 by root t1 t2 radians per second. 1 by root t1 t2 radians per second is the phase crossover frequency. Now see here, this is the phase crossover frequency 1 by root t1 t2 radians per second. At that particular phase crossover frequency, he is asking the magnitude. Okay, so this is omega pc, substitute here. So which is nothing but this is omega pc, now at omega pc 1 by root t1 t2, 1 by root t1 t2, 1 by t1 cancel, t2 to cancel, Now the answer is, now the magnitude is k into T1 T2 by T1 plus T2. If the problem is directly of this particular format, then you can substitute directly, like this the question, g of s equal to 10 by s into s plus 1 into s plus 5, like this the question is given. So directly s into 1 plus st1, but this is a time constant form, you converted first, otherwise don't apply. G of s equal to 10 by s into 1 plus st1, 1 plus st2. Now here this is g of s, which is equal to, take 1 as a common, take 5 as a common, therefore which is nothing but g of s, which is equal to 2 by s into 1 plus st1 into 1 plus st2. Now same format, now which is equal to k by 1 plus st1, 1 plus st2. Now this is the same format, then you substitute. What is t1? Now here t1 is 1, t2 is 1 by 5, k is 5. Substitute here directly. 5 into 1 by 5 by 1 plus 1 by 5. Directly this is the answer. 5 cancel. Now 5 by 6 is the answer. Okay. Now if the problem is of directly same format, then you utilize this particular formula directly and substitute. Let us take this is for example. So this is the way how to calculate the magnitude of the polar plot where the polar plot crosses the any axis. Okay, note down this. Clear or not? This is one kind of problems where he is asking to find the magnitude anywhere. Okay, but use the same procedure and you can determine the magnitude anywhere when the polar plot crosses negative real axis or positive real axis or negative imaginary axis or positive imaginary axis or anything, you can utilize this. But whatever the problem we are solved, that will be coming directly, use that formula directly. Now this is another kind which is very important. Now I want to find the stability of closed loop control system. Okay, we want to find the stability of the closed loop control system from the polar plot. Okay, now we want to find the stability of closed loop control system. I want to find the closed loop control system stability, but from the polar plot, because the polar plot is the frequency response of open loop transfer function. Okay, so let us take one example such that you can easily understand. This is the polar plot which is already given to you. When polar plot is given, which means that the direction is given. Without direction, there is no meaning of polar plot. This is the polar plot of open loop transfer function which is given to you. And sir, what is the given? What is any another information which is given? Yes, there is another information which is also given to you. This is magnitude 1 circle. This is magnitude 1 circle. Now this is a given polar plot. Now students, which is very important point you just observed here. Okay. Now what is given is, this is the magnitude 1 circle. This is the magnitude 1 circle. Now if it is magnitude 1 circle means what is this? This is -1. What is this? This is +1. What is this? This is plus J1. This is plus J1. What is this? This is minus J1. Now, this is the magnitude 1 circle. Why? Because -1 magnitude is 1, minus J1 magnitude is 1, plus 1 magnitude is 1, plus J1 magnitude is 1. Square root of a square plus b square, square root of a square plus b square, square root of a square plus b square. Now see here, this is the magnitude 1 circle, right? Now earlier I am giving one point, concept of enclosed. Now I am mentioning point x, point y. What is point x, point y? No point x, no point y. That point is nothing but -1 comma j0 point. This is -1 real part. There is no imaginary part. Therefore this is -1 comma 0 point. Sir, why -1 comma 0 point? Because this is the open loop control system transfer function. What is this? This is the open loop control system transfer function. You are dealing this open loop control system transfer function with respect to -1 comma 0 point. Then that particular relation is nothing but the relation of closed loop control system. There are three conditions such that the link of open loop between and closed loop control systems are magnitude condition, angle condition, point condition. So this is the point condition. So this is a point condition which we are using here to link between open loop and closed loop control system. Sir, by looking this polar plot, how to find the closed loop control system stability? If you want to find the closed loop control system stability from the polar plot, now first we want to find a gain margin and phase margin. Okay, so you know how to find a gain margin, you know how to find the phase margin, but without calculating gain margin, without calculating phase margin, can I able to find the stability of the closed loop control system just by looking the polar plot? Answer is yes. Sir, what is that shortcut method? Then I am giving one shortcut method. First you follow. This is -1 comma 0 point, and this is the polar plot direction, which is very important. This is the polar plot direction. This is right hand side region and this is left hand side region. Now your -1 comma 0 point is enclosed or not enclosed? Right hand side enclosed, left hand side not enclosed. Remember the students, one shortcut method. If -1 comma 0 point is not enclosed by the polar plot, definitely its corresponding closed loop control system is stable. Understand or not? If -1 comma 0 point is not enclosed, this is the polar plot direction, but this is not enclosed, this is right hand side, this is left hand side, not enclosed, closed loop control system is stable. I am writing the answer directly. So without doing anything, -1 comma 0 point is not enclosed, therefore closed loop control system is stable. Definitely I can say that gain margin is positive. Definitely I can say that phase margin is negative. But in your mind there is some confusion. Is that statement is correct or not? Not enclosed is stable is correct or not? You can cross check. We can verify. So this is -180 degrees line, means angle, and here I can touch here. Now you tell me what are the points here. This is nothing but magnitude. What is the magnitude? minus 0.5. What is the phase angle? Minus 180 degrees. And what is the frequency? When phase is minus 180 degrees, this particular frequency is called as phase crossover frequency. And what is the magnitude here? This is the magnitude 1. Phase angle is, this angle is given. This is the clockwise direction, therefore minus 30 degrees. When phase angle is minus 30 degrees, this particular frequency is called as gain crossover frequency. Therefore, what is the magnitude? Magnitude of G of j omega. Magnitude of open loop transfer function. Phase angle of open loop transfer function at some particular frequency. Right? Magnitude, phase angle at some particular frequency. Now, what is the magnitude? The magnitude, which is nothing but minus 0.5. Phase angle, angle of G of j omega at some particular frequency. Sorry. What is the phase angle? The phase angle is minus 180 degrees. When phase angle is minus 180 degrees, this particular frequency is called as phase crossover frequency. Now, what is the gain margin? The gain margin is nothing but reciprocal of magnitude of open loop transfer function at phase crossover frequency. At phase crossover frequency, what is the magnitude? So, at phase crossover frequency, the magnitude is 0.5. At phase crossover frequency, the magnitude is 1 by 0.5, 10 by 5, which is equal to 2. This is the gain margin. But I want gain margin in terms of dB. What is the gain margin in terms of dB? 20 log 2 base 10, which is equal to plus 6 dB. How much gain margin you are getting? Plus. But how much you are saying? Plus. Because it is not enclosed, stable. No, sir, I can calculate a phase margin, whatever it may be. What is the phase margin? Magnitude of open loop transfer function. Magnitude of open loop transfer function. Phase angle of open loop transfer function at some particular frequency. What is the magnitude? This relation I can take. Magnitude is 1. Phase angle is minus 30 degrees. When magnitude is 1, this particular frequency is called as gain crossover frequency. I am not interested in the gain crossover frequency. What is the phase margin? The phase margin, which is equal to 180 degrees plus angle of open loop transfer function at gain crossover frequency. At gain crossover frequency, what is the phase angle? The phase margin, which is equal to 180 degrees plus angle of open loop transfer function at gain crossover frequency is minus 30 degrees. Therefore, what is the phase margin? 180 minus 30 degrees, 150 degrees. This is the phase margin. This is the gain margin. Now your phase margin is positive. Your gain margin is positive. Closed loop control system is stable. But without calculating this, you are saying that system is stable because minus 1 comma 0 point is not enclosed. Sir, if what happen if it is enclosed? Sir, what happen if it is interested? Then all the combinations we will see. But this is the way how to calculate the closed loop control system stability from the polar plot. One point I want to say, don't find gain margin, don't find phase margin. In the same example, this is the previous GATE examination 2 marks question. He is asking find gain margin, phase margin. Students are trying to find out with this particular procedure, but that is not the thing we have to apply the GATE examination. Now the one student will think like this, not enclosed. Therefore system is stable. And you already know that the gain margin, phase margin is positive. And see the options in this particular GATE examination. All the options are negative options. Only one option is positive. But you know that gain margin is positive, phase margin is positive. Directly go to the positive options. Don't find these calculations and all these things are not required. Sometimes it is useful like this. The technique is also useful like this. Understand or not? So this is the way how to find the gain margin and phase margin for the given polar plot. This is the open loop transfer function and this is minus 1 comma 0 point. The link between open loop transfer function and that point condition is nothing but the closed loop control system relation. Okay, note on this. Okay, so this is the way how you calculate the closed loop control system stability from the polar plot. We will see a number of combinations. Okay, but now one question is given like this: the magnitude. What is the question is? Magnitude and phase angle. Magnitude and phase angle of open loop control system transfer function at two different frequencies. At two different frequencies as follows. Magnitude and phase angle of an open loop control system at two different frequencies as follows. Then determine closed loop control system stability. Now what is given is now this is the relation which is given. Magnitude and phase angle of an open loop transfer function at two different frequencies as follows. Then determine closed loop control system stability is the question is given. Okay, now see here. So by seeing these relations of magnitude and phase angle, so can I write like this? Now what is magnitude? Magnitude is 0.1, phase angle is -180. Immediately in your mind you want to answer. Here this is a magnitude and phase angle at one frequency omega n, but when phase angle is -180 degrees, this is not omega n, this is called as this omega n is nothing but omega pc. When phase angle is -180 degrees, this particular frequency is called as phase crossover frequency. At phase crossover frequency, what is the magnitude? Magnitude is 0.1, 1 by 0.1, 1 by 0.1, which means nothing but 10. But what is the gain margin in terms of dB? 20 log 10, which is equal to 10 now plus 20 dB. Now one more relation is also given. 1 at angle of -150 degrees at some particular frequency omega 2. Whenever in your mind you want to think that when magnitude is equal to 1, this is not omega, this is omega GC. This is omega GC, gain crossover frequency. At gain crossover frequency, what is the phase angle? At gain crossover frequency, the phase angle is -150 degrees. Therefore, now the phase margin is 30 degrees. When phase margin is positive, gain margin is positive, then the closed loop control system is stable. The closed loop control system is stable because gain margin is positive, phase margin is positive. If sometimes he is giving the relations, whenever he is giving the relations, then you can find a closed loop control system stability with this manner. Okay, note on this.